During this pandemic, many students have been on screens for a lot more time than they have been used to. This causes eye strain, headaches, discomfort, and more. Hi, my name is Shrishpam Krishna, and my Science Odyssey project for this year is going to try to combat this issue. My project is using AI to grade students' physical paper assessments. Before I dive into the project, let me first tell you the inspiration for this project. Last year, I had the opportunity to participate in Alameda County Science and Engineering Fair. There, I saw other middle school students presenting projects which use machine learning models to solve problems like detecting diabetic retinopathy and to avoid head-on collisions in automated cars. These projects inspired me to learn about machine learning and artificial intelligence. After distance learning started, I started feeling screen fatigue, and I wondered if I could use my new skills to make the situation better, and this is how my idea was born. Before I jump into my project, let me first tell you how I envision my project. Here are some excerpts from my physical lab book. Step 1 was a teacher creates an assessment and an assessment key. Step 2, the student completes the assessment and then they complete it by shading and marking either A, B, C, D, or none in the multiple choice boxes. Then they take their phones to scan the assessment. Step 4. The pictures of the assessment go through an object detection function to detect the multiple choice boxes with markings. These multiple choice boxes with markings then go into a classification model, and this classification model predicts what answer was shaded. After that, the evaluation algorithm uses the predicted answers and compares it to the answer key and gives a predicted score. That was my first envisionment of this project. You might think that this sounds a lot like OMR, optical mark recognition. Yes and no. My project also tries to automate grading of assessments. However, with my project, the question paper can be formatted in such a way that multiple choice question options can be embedded into the worksheet and don't have to be on a separate sheet of paper. Additionally, OMR needs special technology to scan papers, but my project only needs a phone camera which is widely accessible. Here is my materials list. First, you need a PC or a Mac to run deep learning models. You need a connection to the internet and some sort of IDE to edit Python code. The Python machine learning libraries I used were NumPy and Pandas to pre-process my data, Matplotlib and Seaborn to generate graphs and tables, scikit-learn for machine learning algorithms, TensorFlow and Keras to build my convolution neural networks, and OpenCV for my object detection. Now, let's move on to the procedures I used. I split my project into two parts, the MCQ classification model and the grading system. MCQ stands for multiple choice questions. I split my first part of my project into three parts. First, I have to generate training data, then I use the training data to train my model, and then I save my model to be used in the grading system. In grading system, I use object detection to identify the MCQs on the assessments. I use my MCQ classification model to make predictions on these MCQs, and then I use the predicted answers and I evaluate, which means I compare the answer keys against my predicted answers. Then I use an evaluation algorithm to find the score of each assessment. I then display the score, as shown here. Here are a few more examples of how my grading system looks in action. Here is where I do my coding. Let me run you through some of the files on the left. TrainModel.py has the code that I use to train my models. Preprocessed data has the code I use to preprocess data to train my models. And GradingSystem.py is a culmination of this project, and I use it and it has a code to predict and score assessments. Let me run GradingSystem.py to show you it live in action. Here we are. and you can just click enter and go through all of them. Here are my results. As you can see, I ran 5 and 20 epochs. When I ran 5 epochs, I barely reached the accuracy and loss levels I wanted. But when I ran 20 epochs, I reached the levels I wanted, but it overfit. So I chose to use 10 epochs. Here, the accuracy and loss levels are where we want, but it's not too erratic, nor does it plateau too much like 20 epochs. This is the model I ended up using for my project. Here, I made a heat map that shows how well my model did against 4 people taking 5 assessments. In total, there were 88 questions. All the A's were predicted correctly, all the B's were predicted correctly, all the C's were predicted correctly except 1, all the D's were predicted correctly except 2, and there were 2 none, and 1 was predicted incorrectly. Here's the heat map. This tallies up to a 96% accuracy. My goal was to use artificial intelligence to reduce the amount of time students spend on screens taking assessments and tests. I achieved my goal with this project. My project is able to scan physical paper assessments, identify the multiple choice questions on the paper, and is able to predict the answer selected with an accuracy of 96%. The next steps for this project. For this submission, I mainly focused on the machine learning model of my project. There are a few next steps for this project. First, develop the user interface for teachers to make their own assessments and for students to scan and take pictures of their assessments. 2. To improve the accuracy of the machine learning model close to 100%. Impact. The deep learning model developed for this project can be used post-pandemic to automate physical paper assessment grading in schools. It will help our teachers cut down massively on the time they spend on grading assignments by letting them just take pictures of the assessments and automatically grade them in a split second. This solution will be a great value addition to learning management systems such as Schoology, Schooloop, and Canvas.